We are going to work on this problem. We have two limbs of one fold and we are supposed to find out the geometry of the fold. As you see in this diagram, our fold in a space can have different orientation and different type of plunging, right? So based on these two attitudes that we have, we are going to find out these fold in a space is similar to which one of these folds. Okay, in this diagram you need to find two elements and plot it on this diagram and come up with the shape. So on the x-axis you have a dip of the axial surface. Indeed, you need to find the axial surface of the fold and then read the dip of that plane. And on the y-axis you need to have a plunge of hinge line. So the hinge line indeed is the fold axis and you need to find the plunge of it. So what we're going to do, we are going to plot these two, find the fold axis and the axial plane and read the plunge and the dip respectively. So let me bring my Stereonet and I'm going to work on this. So here it's my north and south. So one, it says it's the strike is 61 and the dip is 48 towards southeast. Okay, 61, 10, 20, 30, 40, 50, 61, and is dipping towards, I'm gonna call this one A, and is dipping towards southeast, right? Let's put this one here, east and west. 48 southeast, so I need to bring the A on north-south line and then count 48 degrees from southeast. 10, 20, 30, 40, 48. Okay, I'm gonna draw my plane here. And the next one is saying the limb is 28, 55 northwest. So the strike is 28, 10, 20, 28. Let's call this one B, is dipping towards northwest. How much? 55 degrees. So I'll put the B on the east-west line and I'm count from the northwest direction. 55 degrees. So 10, 20, 30, 40, 50, and 55. Okay, cool. So this is what we got. So far, we can say the intersection of these two limbs, right? This one, this shows the axial plane, this shows the fold axis, right? It has a trend and plunge, so we need only the plunge of that, so we need this angle, right? So for counting this angle, you place it to the east-west line and you actually have this one 20 degrees, right? 10, 20. So I have my fold axis, which plunging towards southwest, 20 degrees. And the next step, I need to find the axial plane. And based on the definition, we know the axial plane is dividing the structure in two symmetric portion. So what I'm gonna do, I need to actually divide this angle between A and B symmetrically. So how I can count the right angle? So you see there was a different distances, right? here. So the right one indeed is you should count the angle on the profile plane of the fold axis. So let's find the profile plane. You place this one here, right? From here you count 90 degrees. So I see here it's 20 degrees. I can easily go from the center 20 degrees to that direction, and you can, dash these profile plane to the axial fold. Okay, and this is indeed the great circle that you should count the angle between A and B. So what is the angle? So here this is, let's say, 8, 18, 28, 38, 48, 58, 68, 78, and another 6, which is 84, right? This angle is 84. So I'm gonna write somewhere, let's say we write this one here, 84 degrees for this one. And you need to divide by 2, so it's gonna be 42 degrees. And let's find where is 42. Again, 8, 18, 28, 38, 40, 42, right? So this is indeed the central point of this angle, 42 degrees. Okay, so now if I draw a great circle going through this point, the central point, and the fold axis, it's gonna give me the axial plane. So let's put the orange point and the cross on a great circle. Probably here, yeah, something like that. So I'm gonna do with this one with a different type of dash line. Let's do like this. Right? Okay. So since we are, at the right location, we can actually count the dip of this plane. And as you see, it's almost, close to vertical. So here you have 5 degrees, or you can say this axial plane has a dip of 85, right? So you need to count the angle here. We are going to read the dip, and that's 85. So let's go back to the original position. So we know the axial plane has the dip, has the plunge of 20, right? The plunge of 20. And the axial plane has a dip of 85. Okay, we need these two numbers. So let's bring this one up. And as we said, the plunge of the hinge line, it's 20 degrees. So here you have 10, 30, and 20. It's going to be somewhere here, right? Let me bring this is, let's say it's 20. You place that one there, you draw your line. And then the other one, the dip of the axial plane, dip of the axial surface or axial plane is 85. So here's 10, 30, 60, 80, 90. So here it's 85. And you draw this line. And the intersection, indeed, which is saying gently plunging, okay, gently plunging anticline, indeed is the geometry of this fold. So in a space, this fold looks like similar to this. Okay, as you see, the axial plane, it's pretty much vertical, and the plunge is about 20. So if I'm going to show it here, this angle, okay, is 20, and this angle with respect, to the horizon and the axial plane, it's 80.